Today we'll be looking at the measurement of phase difference using the Lissajous figures or Lissajous curve. This is also known as the Bowditch curve or the Bowditch figures by Bowditch. Nathaniel Bowditch. First of all, let's look at how the circuit will look like, how we'll connect this circuit for the Lissajous figures. First of all, we have our oscilloscope, we have our oscilloscope, in the dual mode, we put this on the dual mode. Now, if you check here, you can see that we have put this on the dual mode, the two channels, the X channel and then the Y channel, We will be making two connections, one on the X and then one on the Y channel, and their respective voltage, volt per dive or voltage, and then their time per dive, So normally when we on any oscilloscope, it should show us a straight line, That's when you are using only one channel. When you are using only one channel, you see only one line. But because we are using both channels, dual channels, if I put this on channel 1, you see, once I put it on channel 2, you only see one channel. If I put it on the channel 1, you also see the other channel. So this is channel 1, and then this is channel 2, And then when we put it on dual, we should be able to see both channels here, So that's for the channels. So our oscilloscope, then the next thing should be our function generator, our function or signal generator, This will be able to help us to change the frequencies that we are looking for. We will change the frequencies that we are looking for, And then our third thing should be our transformer. So we are using 240 to 12 volt transformer. It's a step down transformer, This is our step down transformer. Of course, our secondary side of the transformer has 3 terminals. We are only using the 2 other terminals, leaving the center tap. So we are not interested in the center tap, And then that is connected to our breadboard. You can see this is connected to our breadboard. So we connect it to our breadboard, this way. Now, when we do that, we have to now come and fix our 2 channels. Let's try and now fix our 2 channels, We take our cable, We take our cable, we connect one channel here. So this is the first channel, We connect one channel this way. This is the first channel. Then we take the other cable. We take the other cable and connect it to the other channel, Y. So now we have 2 channels connected to our oscilloscope, One here and then one here, So these are 2 channels. This is for the X channel, which is the channel 1, and then this for the other one, which is the channel 2, this way. Once we do this, the next thing we do is we connect the channel 2, the Y channel, to our function generator, so this way. So we connect the other channel to our function generator. So we take the 2 ends of our cable, of our wire, and then we connect this to the positive side. Then we connect this to the negative side, like this. So now we've connected this channel all the way to this side. Then we also come to this side, the transformer, So we take this particular channel, And then we connect it to the transformer, the other end of the transformer, this way. So like this. So we've connected it to the transformer on the breadboard, this way. Now when we do that, from our circuit here, From our circuit here, from this circuit, you realize we are supposed to connect from the function generator. This should be our output, and then there should be a capacitor. So the value of this capacitor should be 1 microfarad. And then our resistor value should be able to be, let's say, 470 ohms. 470 ohm capacitor, resistor, okay? So this is our 470 ohm resistor. This is our 470 ohm resistor, right? This is our resistor. And then we can be able to connect it to the breadboard. And then this is our 1 microfarad capacitor, okay? So now that we've connected this side to the transformer and then this side to the transformer, what we do next is to connect the resistor and then the capacitor this way. So we can connect this way, right? Then we connect this one also this way. So from one end of the transformer to the other side of the channel. Then what we do next is that we can now bridge this side. Okay, so we have to now close this side. So you can use these two connecting wires to connect this side. You see, now we've bridged this port to this port. So we have to also bridge this port to this port. Okay, so we also connect the other side here. So now we've bridged the circuit. Now we can now on it. So we can now on the transformer. Okay, see, when we on the transformer, we can see both the transformer frequency or the wave, and then we can see that of the function generator. Now let's do a little bit of settings here. Okay, let's do a little bit of settings here. You can see there is some XY channel here, right? So we have to put this on the XY channel this way. You see, once we put this on the XY channel, we will start seeing the Lissajous figures. Okay, so what we do now is we can now vary the frequency on the signal generator. Now we are starting from 50 hertz. Okay, so we are using 50 hertz frequency because our frequency coming from our source, right? The frequency coming from our source, which is our AC source, the transformer, is 50 hertz. So we have to also set this to be 50 hertz so that we can have the 1:1 ratio. Okay, so that we can have the 1:1 ratio, this particular ratio here, right? We want 1:1 ratio. Okay, so now let's set this to 50 hertz. Okay, so you see, so when I set this to 50 hertz, I'll start seeing the Lissajous figures. So per our diagrams, right? This is what we are seeing here. Okay, we can see there is a So this is our 1:1 ratio. Okay, this is our 1:1 ratio. This is our 1:1 ratio. Okay, so that's the 3D model. Now in the other video, you know how the Lissajous figures works. Okay, now we've been able to combine both frequencies coming from, you see, there is one frequency coming from the transformer, our AC source, and there is another one coming from our function generator. We've combined them, so because they are perpendicular to each other. Okay, so that's what we are seeing here, right? That's what we are seeing here. Now, how do we vary? So you realize that our 90 is when it becomes full. Then our 45 is when it becomes oval. Okay, oval. And then our 0 degrees is when we get a straight line. When we get a straight line, is our 0 degrees. Our 0 degrees becomes our straight line. And then our 180 is when it gets this way. Okay, so now we can calculate the phase difference. So you should be able to draw this and then calculate the phase difference. Now let's look at the way we can generate the 1:2 ratio. Now we said that if the frequency coming from our source voltage is 50 hertz, right? And then we've also set this to 50 hertz. That is 1:1. Okay, so that now becomes 1:1. 50 hertz is to 50 hertz, right? Now it means that our 1:2 ratio should be 50 hertz to 100 hertz. So it's very simple. So what we do is that we set this, we keep, you see, realize that the frequencies that are coming from our transformer, we maintain them. So here will be 50, 50, 50, 50. Then here will be 100, 50, 100, 150, and then 200. So that's how we set our ratio, okay? Then we use it to calculate our phase difference. So let's see the 1:2 ratio. Let's see the 1:2 ratio. Let's see the 1:2 ratio. So we set this to 100, okay? We set this to 100. So you realize that once I start moving this to 100, so these are 100, okay? These are 100. So this is 1:2, the ratio. 50 hertz from our source, which is our transformer, and then our AC, right? And then 50 hertz from our function generator, 100 hertz from our function generator. So that's what we are seeing. So you realize that it resembles what we are seeing here. Let's do the comparison. Let's do the comparison. Okay, you see, so this is what we are seeing now. This is what we are seeing now. You can see that it resembles all this. All these figures are being generated on the screen now. So this is our 50 hertz to our 100 hertz frequency. 50 from our AC source, 100 from our function generator. So these are the signals that we are seeing now. Then we can generate or calculate the phase ratio or phase difference, okay? In the other video, we will look at how it is calculated. So this is how you can generate the Lissajous figures. Now let's go to 1:3 ratio, okay? So that we see whether we will really get what is here. So 1:3 means that we have to put this on 150, okay? We have to set the frequency to 150. So what we do is now, we put this, we change the range here. When we change the range, then we put this on 1.5. Okay, so you realize that this is very beautiful. So this is our, excuse me. So now this becomes our 1:3 ratio. 50 hertz from our transformer, 150 hertz from our signal generator. 50 hertz from our transformer, 150 hertz from our signal generator. So you realize that you can see this, right? Now this is the first one. And then you see, we see the second one, we see the third one at 90 degrees. So we can see 0 degrees, 30, 45, 90, 135, and 180 degrees. So that's what we are seeing there, okay? That's what we are seeing there. So that's the setup. This is how we do the Lissajous figures, or some people will call it Bowditch curve, okay? It's very beautiful and interesting. Let's look at the fourth ratio. The fourth ratio. Let's look at number 4, okay? This, which is 1:4. So 50 hertz from the source, from our AC or the transformer, then 200 hertz from our function generator, okay? So let's try and set that. So now so that's our 200 hertz. That's 200 hertz. So you can see it's exactly what we see in the diagram, right? It's exactly what we see in the diagram. Now we can go on and then generate 1:5 ratio, 1:6 ratio, 1:8 ratio, up to the number of ratios you want to generate per the transformer frequency, 50 hertz, and then the function generator frequency. Get it? So to generate to realize that what we are seeing here, this is exactly what we are seeing here, right? So this is exactly what we are seeing here. Okay, so this is how we generate the Lissajous figures. Okay, so we can go ahead and then add 50 to the signal generator and then see how the ratio. You see, our book didn't give us 1:4 frequency, but we can generate 1:5. Okay, it didn't give us 1:5, so let's try and generate 1:5. So we just add 50 hertz to our function generator frequency, right? We just add 50 hertz to it. So we go to 250. So we put this on 2.5. So these are analog. Okay, so that's, you see, that's exactly on 2.5, and then see. So that is our 3D model of the two signals. We have one signal or waveform from our transformer, and there is another one from our function generator. We've combined the two, and that's what we are seeing there. It looks like a crown. You see, it looks like a crown. It looks like a crown. Let's proceed to see how our 1:6 ratio will look like. Okay, so we just add 50 to this, so we increase this to 300 hertz. So that is 300 hertz. So that is 300 hertz. Let's increase it to 3.5, which is 350 hertz. So this is 350 hertz. Let's go to 400 hertz. 400 hertz. So that is 500 hertz. That is 600 hertz. This is 700 hertz. This is 800 hertz. And then that is 1000. That should be a 1000 hertz. 1000 hertz frequency. Okay, so the Lissajous figures is a very beautiful figures, and then this is how it is done. For further questions, you can leave your comment in the comment section and I'll attend to you. There's a part 2 of the video. You can check it out. How the phase difference can be calculated. How we can calculate the phase difference. 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 So you can check out for the part 2 of the video. Okay, we'll see how we can calculate the phase difference. Okay, using this diagram. So thank you very much. Thank you very much. Thank you very much once again.